Hello. Today we are going to start with multiple expansions. We were doing this topic yesterday also, and today we are going to continue from there. So just let me wait for a few people to join in, and meanwhile I'll share you the screen. Okay. So till now we've done multiple expansion. We have derived an expression for it, and we have also done a few of the related things in Legenders column that I have separately taught you under the heading of special functions. So one who's new to this can go and see all those things. Okay, so just give me a minute. Okay, so just give me a minute. So, and let other people join. Okay, so meanwhile, when the other people join, let us start with the problem. Let us start with the problem, and it's a very simple problem. So I hope it will not take much of the time. So meanwhile, while the people will join, let us do this problem. Okay, so okay, so it says that this is the arrangement. So I'm just showing you the arrangement. Given the arrangement, what is that arrangement? Arrangement is this. And what is this arrangement? This is 3q 0, 0, a and q at 0, 0, a and another minus 2q at 0, a, 0 and another minus 2q at 0, a, 0. And it says find an approximate find. Okay, so let me. Okay, so question says find an approximate formula for the potential. Formula for the potential valid at points far away from the origin. Okay, so this is the question, and if I want to do this question, let me just give you a brief revision of what we have done already. So what we have done already is that one of the techniques is called as multiple expansion, in which potential at some distant point is given by the contribution of potential due to monopoles, that is simply charges, potential due to dipole arrangements, then potential due to quadrupole arrangements, so on and so forth. Okay, so this is what we've done, and this we have done for continuous case also. Mostly we have derived this expression for a continuous case. Now here you can see that the totals, what is V monopole? If you remember, V monopole was given by 1 upon 4 pi epsilon naught and integral rho d tau. Okay, so if the charge is distributed uniformly along the volume, then this is rho d tau. If it is distributed uniformly along the surface, then it is sigma ds. And if it is distributed uniformly along line, then it will take the form of lambda d. Overall, this represents the total charge of the system. This represents what? This represents the total charge of the system. And here in this particular question, you can clearly see that the total charge of the system is 0. Minus 2q is minus 4q and 3q plus q is 4q. So total charge of the system is 0. So in any case, V monopole would be 0. If total charge is 0, then V monopole would be 0. Now we should find what is V dipole. We should find what is V dipole. And in order to find V dipole, one needs to find what is the dipole moment. Okay, what is the dipole moment? Because one knows that dipole moment dot r cap upon 4 pi epsilon naught r square. This is your potential due to dipole. So if I know my dipole moment, I will be able to find the potential due to dipole, and this is in general r. This is in general r cap. Okay, and so this is r cap. So let us first find what is p vector. So your p vector would be equivalent to writing. Sorry, so 3q was along 0, 0, a. So this is p vector can be written as summation ri vector, and that is qi. That is the position vector of the qi vector, and I is equal to 1 to 4. There are 4 charges. So 3q is placed at k cap, then q is placed at minus a k cap, and then there are 2 charges minus 2q a j cap, and then again minus 2q minus a j cap. So overall, this term gets cancelled, and this will give you 2a q k cap. So this is your p vector. So your p vector comes out to be equivalent to 2a q k cap. And what would be potential at any faraway place as a function of r? It will be p vector dot r cap divided by 4 pi epsilon naught r square. So in general, if this is your z-axis, and let's say this is in general r vector, and this is k cap, this angle is given by theta. So this will give you 2aq cos theta divided by 4 pi 2aq, no? So 2k, sorry, it will give you 4 pi epsilon of r square. Okay, this is how this potential due to this dipole would be. And see, at very far away places, so at very far away places, far away points, I would say, the potential due to dipole would dominate. Potential due to dipole, or you can say, because since dipole is the leading term, will dominate. Is that clear? So potential in general, here it was potential is potential of dipole, I write. So approximate potential would be equivalent to the leading term. So approximate potential as a function of r would be equivalent to V dipole, and that V dipole is given by 2aq cosine theta divided by 4 pi epsilon naught. I hope it is clear. Is that clear?
Yes, sir.
Okay, good. Chalo. So some of the discussions that we were doing yesterday also. So let us resume that discussion so that okay. And let me try another question for you. Let me give another question. Okay. So the question says that a few questions on dipole only. So let us do a few questions on dipole so that okay. So a few questions on dipole. So another question would be the dipole moment is being asked. The dipole moment of a thin charged rod bearing charge density rho is equal to lambda Dirac of x Dirac of y for z belongs to minus a comma a is. What do you think that dipole moment for this thin charge rod bearing this kind of charge density where z belongs to minus a comma a would be? So this is what is asked. This is what is asked. Okay, so I think this minus a comma minus a should be okay. So what do you think would be an answer to this? Okay, so let us try. So as I mentioned, for continuous distribution, we have this kind of expression for the dipole moment. Is that clear? I mean, this is something that you know, and we derive all these things for mostly volume charge distribution. Instead of volume charge distribution, if linear charge density is given, then dq will be equivalent to lambda dl. However, here the volume charge distribution, volume charge density is given, but I'm just saying that it may take this form also. Okay, it may take this form also. Is that clear? Okay. Now, first, let me know where the charge would be located. Do you have any idea where the charge would be located? Seeing the charge density. Alpana, do you know where the charge would be located?
Axis.
Haji?
Along xy axis.
Along xy axis.
Delta x और delta y. और z लिखा हुआ है ना, सॉरी, तो z एक्सिस पे होगा.
Okay. Bharat, what do you think the charge density would be located in?
Sir, I think it's at the origin.
Okay. Okay. Just give me a minute. थोड़ा सा एक तो ये डायग्राम बड़े गंदे बन जाते हैं मुझसे. चलो कोई नहीं. Okay. Okay. So let me draw the graph. This is one. Okay. So see, lambda x and lambda. I taught you on the very first day that Dirac delta function will be operational wherever your argument is equal to 0. If it is not equal to 0, then this would be 0. So if x is not equal to 0, then Dirac x would be what? It will be equal to what? 0. And similarly, if y is not equal to 0, then Dirac y would be equal to 0. So it will be only operation if x is equal to 0 and y equal to 0. That is only possible if you are along the z-axis. There is no other place. Is that clear? So your charge density
Yes, sir.
in form of line, it is expressed in form of lambda x and lambda y. So that implies that your charge density is all along z-axis. Is that clear? And that z is varying from minus a to plus a. So your z is varying from minus a to plus a. Is that clear? And what was this r vector? R vector was the location of the dq vector. So let us take a dq vector here. So this is, r vector was the position vector of charge dq. So let us take at a distance z, this dq. Is that clear? Let us take at distance z, this dz. Is that clear? Let us take at distance z your charge dq, because your charge will be located along the z-axis. Is that clear or not clear? I'm just making an exaggerated figure.
Yes,
It will not
sir.
be in this way. बिल्कुल एक line ही होगी. Are you getting my point? So we are taking a small charge dq. Is that clear? हाँ या ना तो बोलो फटाफट से.
Yes, sir.
Okay, good enough. So what will be your r vector? R vector I'm writing z. Okay, r vector would be z. And what is dq? dq would be rho dx into dy into dz. Is that clear? And what is rho? Rho is given by, I think rho is given by lambda, Dirac x, Dirac y, and then you have z, and then you have dx, you have dy, and you have dz. Okay, so now you can clearly see that your system is along z-axis, right? Your system is along z-axis, so it will be equivalent to writing lambda Dirac x dx integration Dirac y dy, and I can write integration z dz from minus a to plus a. Is that clear? Yes or no?
Yes.
And along z-axis, you know that your y is 0. So this integration would give you 1. This integration on any limits would give you 1. So this integration is 0. You clearly see that your z dz would be equivalent to what? Minus a to plus a, it would be 0. So overall answer would be what? 0. So the net dipole moment would come out as null vector. Is that clear or not clear?
Yes, sir.
Okay, so this is just हल्का सा confusion create करने के लिए दिया गया है, but बाकी ऐसा कुछ है नहीं difficult. I hope it is clear. And we'll also see, थोड़ा सा अगर आगे बढ़ेंगे तो we'll see that if there exists a point of symmetry. So for example, जैसा charge अगर if it is uniformly distributed, so जैसा charge आपका ऊपर की तरफ distributed है वैसा वैसा charge same it is distributed below z equal to 0. So z equal to 0 is a point of symmetry. So we'll see later on when I'll discuss origin of coordinates, you'll be able to get it, get more insight into this. Is that clear? Should I move ahead?
भैया.
Yes.
Okay, good enough. So we have already done till now. I think we've already done क्या कह सकते हैं multiple expansion. And let me just revise it for you. That this is what we've done. We had this. We had this. You can say volume, and having arbitrary charge distributions. We don't know about the charge distributions. And at any distance r, let's say this is your origin, and these coordinates were taken to be r prime. This coordinate was taken to be r. Like this is what we did now. This is what we did. Let me just check so that we are not making anything wrong. Okay, so this is what we did. This was r vector here, and this is r vector minus r vector dash. and we developed a potential as a function of r. We developed potential as a function of r, like I think 1 upon 4 pi epsilon naught, and there was I think r ki power n plus 1 sums n equal to 0 to infinity, and there was integral r dash ki power n pn. I think there was cos theta dash, and then there was a rho r dash, and then theta dash. Is that clear? So this is how you can express your potential as a function of r. And for different other n's, you'll find that this expression would give you a different contribution. So if for n equal to 0, you will get a contribution for the potential in for corresponding to monopole. Then for n equal to 1, you can get potential corresponding to dipole, so on and so forth. So you knew that potential is directly proportional to 1 upon r. Electric field is directly proportional to 1 upon r square. For n equal to 0, you will get a dipole contribution, which was equivalent to writing plus and minus, and the potential was directly proportional to 1 upon r square. Electric field was directly proportional to 1 upon r cube. For n equals to 2, sorry, n equals to 1, you will get what you know as your quadrupole arrangement. And one of the quadrupole arrangement can be to draw a square quadrupole, which will have plus minus, plus minus. So equal and opposing dipole moments would be there. And here your potential as a function of r would be inversely proportional to r cube, and your electric field will be inversely proportional to r ki power 4. And for n equals to 3, you will get a octupole arrangement. And I made a diagram also. It like I think some diagram like this. So it will have one plus minus, plus minus, plus minus, and then minus and plus. So this is an octupole arrangement where your VR would be inversely proportional to 1 upon r ki power 4, and electric field would be inversely proportional to inversely proportional to r ki power 5. Inversely proportional to r ki power 4. Is that clear? This is something that we have already done. So we actually found a potential expression for very far away points, and without knowing what actual sort of distribution is here, but we know that at faraway points, this potential can be expressed as some sums of potential due to monopole, dipole, quadrupole, octupole, so on. Is that clear? This is something that we've already done. Okay, so let us do a few questions. And instead, what can be given in the examination? Instead of rho, you can be supplied with sigma. And it can also be the case that you are supplied with the linear charge density. Only difference that it would make is that you can see that this particular expression, that is Pn cos theta and r ki power n, occurred because of this distance. Is that clear? देखो, अगर वॉल्यूम की जगह कोई लाइन दे देगा तो भी तो सेम ही एक्सप्रेशन रहेगा. मतलब ये सब चीजें सेम ही रहेंगी. 1/4 पाई एप्सिलॉन नॉट r की पावर n+1, ये सब सेम रहेगा. Only thing that would change is dq. Are you getting my point or not getting my point? Because remember, this particular expression, that is r ki power n Pn cos theta, was generated because of the this r vector minus r dash vector ka mod. So you know that if this angle is theta, if this angle was given to be theta, theta dash, then you know that this r vector minus r vector dash mod can be written as 1 upon, I'll write it here, 1 upon root over, I can write it as r square, then r dash minus 2r dash r cos theta dash. So this is how you can write. And this particular thing serves as a generating function. If you remember, this function serves as the generating function for the Legendre's polynomial. Is that clear?
Yes, sir.
Okay. And for very large away distances, for very far away distances, you can take r common, and you can comment upon what is a leading term. So eventually, one has to understand that if instead of this, some different charge densities are given to me, let's say linear charge density, or let's say surface charge density, all difference that is going to be created is in this expression. Not all other things would remain same. Is that clear? And so I think one of the questions you've already done, there was a spherical system. Now let us do a few more questions. Okay? Is that clear? ये चीज समझ में तो आ गई ना मैं क्या कहने की कोशिश कर रहा हूँ? Okay,
Yes,
good
sir.
enough. Good enough. So let us try to do a few more questions so that इस पे थोड़ा grip आ जाए multiple expansion. So let us do another question, and it says that a charge Q, I'll write plus Q now, plus Q is distributed uniformly. Is is distributed uniformly along the z-axis. Along the z-axis from z equal to minus a, I think, to plus a. Okay, minus a to plus a. Find the expression of potential. Uniform distribution. Okay, find the expression for potential. Expression for potential VR for all r greater than a. For all r greater than a. Okay, so how would you do this question? How would you do this question? How would you attempt this question? This is something that one needs to understand. So eventually we've so that is what I say. That is what I say always. You see the beauty of mathematics. You don't have any like here. तो बिल्कुल पता चल रहा है तुमको कि minus a to a एक आपके पास uniform distribution है charge का. But you see the upper case. See beauty of mathematics. You don't know how the charges are distributed within this volume, but you know for certain that this is how your potential would behave at any r. And mind you, this particular expression has azimuthal symmetry. That is, I am not considering phi. So if I consider phi, then this expression will go into spherical harmonics, and that has not been asked till now in examination. However, I'll cover it for you, and it will invoke some Green's function also, but I will not do that for that. I'll straight away write a formula so that abhi ke liye usko samajh jao. So see the beauty of mathematics. Okay, so that is okay. So let us try to write. So what is required of me? I'll write it is required. It is required. I should write that. I should write a multipole expansion, right? A multipole expansion for the above case. यही तो समझ में आ रही बात for the above case. क्योंकि आपसे पूछा जा रहा है potential in general for the above. So already I know that my charge Q is distributed uniformly along the z-axis, and this is from minus a to plus a. So what would be lambda? I'll write lambda would be equals to Q upon 2a. Is that clear? Total charge divided by total length. Is that clear, beta?
Yes, sir.
Okay. And what should I do? Okay. So instead of rho d tau, my expression would become lambda dz. Is that clear? So instead of rho d tau, or I should write instead of dq, I would write Q upon a lambda dz. Is that clear? And all other things would remain same. Do you understand? मतलब क्या करना है? यहाँ से origin पकड़ा, यहाँ से एक छोटा सा dq एलिमेंट लिया, वही r dash और वही r, एक एंगल यहाँ थीटा डैश लिया, ये dq अब कैसे एक्सप्रेस होगा? Q upon 2a lambda dz. So everything would remain same. Everything would remain same except this, and except this also, because now you're instead of r, are you getting what I want to convey? So देखो मैं तो समझाने की कोशिश कर रहा हूँ. It is this. So now, if you want to take charge, you will take charge from here. So this would be like at a distance z, you will take a charge dz, and again you will make this like from origin. If you take at a very far away distance, so instead of r dash you have z. Here you will have r. So here you will have r vector minus z vector mod, and here you will have theta dash. Everything would remain same. Everything would remain same except for a few things. So this expression would again give you the same multiple expansion thing as you've obtained for the volume charge density, except for the fact that rho r dash d tau dash would be replaced by lambda dz, and this r dash would be replaced by, I think, z. Is that clear or not clear? Is that clear or not clear? देखो सेम वही सेम टू सेम चलेगा. रूट ओवर r square plus z square minus 2z r cos theta dash, and then again you have to take r common out, and everything would remain same. Is that clear? So I will write my potential as 1 upon 4 pi epsilon naught, and there would be a sum going all over from n equal to 0 to infinity, and it will be I should write it in a better way, otherwise बाद में तो मेरे revision करने में दिक्कत आएगी. So potential as a function of r would give you 1 upon 4 pi epsilon naught r की power n plus 1 from n equal to 0 to infinity, and there would be, I think, your z lies between z lies from minus a to plus a, and here you will get, I think, z ki power n. You'll get pn cos theta. You'll get pn cos theta, and then okay, so you'll get pn cos theta, and then I'll get dz. Is that clear? यहाँ तक किसी को दिक्कत तो नहीं ना? ये तो clear ही है. Z की power n pn cos theta dz. Not dz, lambda dz. Rho theta की जगह lambda dz. Is that clear? कहाँ चले गए सब कुछ? Okay. So v as a function of r would give you summation n equal to 0 to infinity 1 upon 4 pi epsilon naught r की power n plus 1, and you will get from minus a to plus a, and this is z की power n pn cos theta dash. So you just एक काम करते हैं ना, इस एक्सप्रेशन को कुछ लिख लेते हैं. Let us write this expression as this lambda को तो बाहर ही ले लेते हैं. So this will be q upon 2a, and you will be left with z की power n, and pn cos theta also you can take out. चलो एक बार बाद में कर लें. pn cos theta एक बार के लिए यहाँ लिखते हैं dz. Since this is theta, this is z, so z is an independent coordinate in the spherical coordinate system. You have cos theta as an independent system and z as an independent system. So this particular, I mean, you can take this because this integration is going over z. This integration is not going over cos theta. So you can conveniently take cos theta outside, pn cos theta outside. So you are left with, I think, summation n equal to 0 to infinity. You have q upon 2a, and then we have 1 upon 4 pi epsilon naught r की power n plus 1, and then from minus a to plus a, I think I should write pn cos theta also outside only. We have z की power n dz. Is that clear to you? Is that clear to you? Is that clear ना? ये चीज समझ में आ गई?
Yes.
Okay. Now, I've taught you in Legendus polynomial. So, like a property from standard 12 that if n is odd, then this integration will become 0. So one thing is pretty sure that you will, in the multipole expansion, you will not have term corresponding to n being odd. Is that clear? Because if n is odd, then z dz would be 0, because minus a to a, if this is an odd function, then things would be 0. And if n is even, certainly this integral would correspond to what? This integral would correspond to z की power n plus 1 divided by n plus 1 and 2 times from 0 to a. Is that clear? बचपन वाला, अगर n even होता है तो this is 2 times integration 0 to a fz dz. So instead of fz, you have z की power. Is that clear? So in totality, your potential as a function of r can be expressed as n. I should write n belongs to even integers, even natural numbers. And it is equivalent to writing q upon 4 pi epsilon naught. I think it should be एक बार ढंग से लिख लेते हैं, r की power n plus 1 here, and then there should be pn cos theta also, and this will be, I think, 2 times, I think this would be upon n plus 1, and this would be a की power of n plus 1. Is that clear? I hope this is clear. Okay. So if you want to express it in a better fashion, so one can do this also. So v as a function of r is equal to sums n equals to 2k, where k is equal to 0, 1, 2. So this will represent your even integers, and q upon, there was some a also, no? I forgot somewhere. So this a is also there. So there would be some 2a as well, right? There would be some 2a as well. So I'll write 2a here. Okay. So this 2 gets cancelled. So q upon 4 pi epsilon naught r, and then I can write 1 upon n plus 1, and then I can write a upon r की power n, because this a would get cancelled. Like this one would get cancelled, this one would get cancelled with this a, and this r की power n plus 1, I'll take r outside. So this is r outside. So this is that clear? So this is your potential. Okay. So this will be your potential for a uniformly distributed charge along the z-axis. Okay. Is that clear? So uniform distribution charge along z-axis from minus a to plus a, I guess. It was there that total charge q was distributed uniformly along the z-axis from minus a to plus a, and it was sought from us that what would be the potential at as a function of r. So this is the expression. This is the expression for the potential. Is that clear?
सर इसमें n क्या होता था एक बार बताएंगे प्लीज, मैं भूल गया।
अच्छा ये हम पूछ रहे हो? ओके सो देखो
मतलब
इसमें
जनरल या फिर हाँ इस वाले में z की पावर।
ओके सो होता क्या था, इफ दिस वाज द केस, रूट ओवर आर स्क्वायर प्लस आर डैश का स्क्वायर माइनस टू आर डैश आर कॉस थीटा, तो हम क्या करते थे, वी यूज टू, बिकॉज यू नो दैट आर इज ग्रेटर देन वेरी वेरी ग्रेटर देन आर डैश, वी आर टॉकिंग ऑफ फार अवे टर्म्स, कॉस थीटा इज ऑलरेडी like you know that cos theta ka mod is always less than 1, and you know that r dash upon r ka mod also less than 1, so you just take r common, and when you take r common out, this term would become the generating function for the Legendre's polynomial. So this n would give you different orders of Legendre's polynomial along with this. So now for different n's, you are going to find different other contribution to the potential. So for example, n equal to 0 would correspond to, I think here अब यही क्वेश्चन तुम्हें टीएफआर वाले पता है क्या पूछेंगे कि व्हाट डू यू थिंक दैट विल डाइपोल बी प्रेजेंट, लाइक इस तरीके से क्वेश्चन पूछे जाएंगे. सो फॉर एग्जांपल इफ n इज इक्वल टू 0, इट विल बी लाइक a अपॉन r की पावर 0, बट एक r यहाँ पर है. सो देयर वुड बी अ मोनोपोल कंट्रीब्यूशन, but there would not be a dipole contribution. You see, if n is equal to 1 here, so if n is equal to 1 here, so this would be 1. Are you getting my point? देखो n की जगह क्या रख सकते हैं, सॉरी n की जगह 0 रख सकते हैं, देन 2 रख सकते हैं, सीधे 2 रख सकते हैं, बिकॉज n ओनली इवन्स आर अलाउड. सो पावर एक n की जगह 0 रखोगे तो q अपॉन 4 पाई एप्सिलॉन नॉट आएगा, फिर n की जगह 2 रखोगे तो a अपॉन r स्क्वायर और एक r क्यूब आएगा. सो यू विल नॉट हैव 1 अपॉन r स्क्वायर टर्म. So potential will not depend upon 1 upon r square. So you will not have a dipole term. You will have a quadrupole term. Are you getting my point?
यस
Or
सर।
not getting my point? मतलब मैं समझा पाया मैं क्या बोलना चाहता हूँ, मतलब तुम समझ पाए
यस
तुम क्या
सर।
पूछ रहे थे? एक्चुअली कुछ नहीं है
मैं
देखो. हाँ सॉरी सॉरी बोलो क्या कह रहे थे?
हाँ हाँ जी सर, मतलब मैथमेटिकली समझ गया था मैं, बट जैसे हम ये चार्ज डिस्ट्रीब्यूशन ले रहे हैं थोड़ा सा, और आर डैश हमारा वेरी कर रहा है क्योंकि
हम्म.
वो, बट वो वेरिएशन हमने शायद चार्ज डेंसिटी में कवर अप कर लिया है,
हाँ जी.
जो आर
राइट
डैश है ना सर।
राइट राइट राइट. डैश
तो
का
फिर
जो
वही मैं,
वेरिएशन है चार्ज डेंसिटी में कवर कर दिया, रो डी टाउ डैश के फॉर्म में या आर लैम्डा डीजेड के फॉर्म में हियर.
जी सर, लेकिन जो आर एन की पावर रहती है वो सिंपल आर वेरिएबल के टर्म्स में, जो कि मतलब फिक्स्ड है ओरिजिन से पी कि जिस पॉइंट पे हम निकाल रहे हैं, तो इसलिए मैं सोचा था, बट वो लेजेंडरी पॉलिनोमियल से आ रही है आप के
मतलब
हिसाब
समझ पाया ना,
से।
ये जेड जो है ना बेटा वो आर डैश ही है. आर गेटिंग माय पॉइंट? देखो ये होता क्या
यस
था,
सर।
ये आर डैश क्या होता था, ओरिजिन से डिस्टेंस होता था ना हमारे. दिस आर डैश यूज्ड टू बी, ये मतलब जो भी यहाँ पे डीटा डैश लिया जाता था ना, इफ यू रिमेंबर आई टुक अ क्यूब काइंड ऑफ थिंग राइट, इधर in the derivation part. So this r dash was the distance of the dq element या dq dash element from the origin, isn't it? So similarly यहाँ पर क्या होगा, यहाँ पे सॉरी यार my mistake. So यहाँ पर क्या होगा देखो, dz कहाँ इस, क्योंकि ये तो लाइन के along ही लाई कर रहा है, so I'll
हाँ
use
जी
this z,
सर।
है ना. So instead of r dash this is z. I hope it is clear. मतलब एग्जाम में इस तरीके से the same question I'm saying in TFR, they're going to ask you the same question in descriptive form. देखना मतलब अगर ये question आया ना एग्जाम में, then they will ask that the leading term would be a dipole term, the leading term would be a monopole term, the leading term would be a quadrupole term, so on and so forth. Is that clear? तो possibly अगर किसी ने मतलब ये कर भी लिया होगा मान लो, तो they will still play with options. So you have to be open enough. Is that clear?
लीडिंग टर्म इस केस में तो वैसे डायरेक्ट पता चल रही है ना, क्योंकि
इसमें तो
टोटल
मल्टीपल,
चार्ज।
इसमें तो मोनोपोली राइट,
हाँ जी यस
है ना. मतलब प्रोवाइडेड अगेन, हाँ प्रोवाइडेड दैट समेशन क्यू इज, अच्छा एक काम करते हैं, लेट अस टेक अ फ्यू एग्जांपल्स सो दैट जो तुम पूछना चाह रहे हो वो भी क्लियर हो जाएगा. सो लेट अस टेक अ फ्यू एग्जांपल इसी सेंस में. ओके गुड इनफ. सो लेट अस टेक अनदर क्वेश्चन. अ थिन, अल्पना को समझ में आया हम क्या बोल रहे हैं?
हाँ भैया.
गुड इनफ. चलो अ थिन इंसुलेटिंग रॉड running from z equals to minus a to z equal to a. Same question. carries a charge density. Carries a charge density. काम करते हैं पहले एक ले लेते हैं. Carries a charge density lambda is equal to ले लो जैसे फॉर एग्जांपल k cos pi z upon 2a, और ऑप्शन नंबर बी ले लो, और एक ऑप्शन आई सॉल्व इट व्हेन थोड़ा सा एडवांस हम कर ले, k टाइम्स sin pi z upon 2a. Here k is a positive constant. K belongs to, let's say, natural number. चलो positive constant लिखो, k is greater than 0. ठीक है. What would be the leading term in each of the cases? What would be the leading term in each of these cases? Okay, तो इन दोनों में लीडिंग टर्म क्या होगा वो दोनों केसेस में? लेट अस ट्राई टू फाइंड इट. ओके, सो देखो, now instead of your uniform distribution, now your distribution depends upon z. So in the previous question, if you could see that you had this kind of expression because you had uniform distribution, isn't it? If you remember. Okay, so let us do this question also. So in this question also, I think everything would remain same. So I'll write b as a function of r would be 1 upon 4 pi epsilon naught r ki power n plus 1. This summation n equals to 0 to infinite. This will remain as ever. So I don't think there needs change here. And from minus a to a, now we have to be certainly cautious. This would be pn cos theta into z ki power n, and then there should be lambda as a function of z and dz. Is that clear? So instead of dq, you have this. Instead of r dash ki power n, you have z ki power n, this pn cos theta. Is that clear?
Yes.
And v as a function of r would represent what? V as a function of r would represent n equal to 0 to infinity, 1 upon 4 pi epsilon naught r ki power n plus 1. And this would be, I think, a pn cos theta you also can take outside, because after all, your lambda is also a function of z only. So this is minus a to plus a z ki power n, and then you have k cos pi z upon 2a dz. Okay, so what do you think would be leading term? So let us first find term. Let us first find the term corresponding to n equal to 0. पहले वो देखें हम लोग. पहले देखते हैं n equal to 0 को, इसको कुछ लिख लेते हैं. So let us write this integral as I या in. So let us first find what would be I naught. If I naught is non-zero, अगर I naught non-zero आ गया, then this will be leading term, isn't it? अगर I naught non-zero आ गया, then this would be leading term. Leading term समझ रहे हो ना, first term. या फिर अदर वर्ड्स में देखो, अगर इसका टोटल चार्ज नॉन जीरो आ गया, तो लीडिंग टर्म क्या आ जाएगा? मोनोपोल 1. मतलब मैं तुम्हें समझा पा रहा हूँ मैं क्या बोल रहा हूँ? देखो,
yes, sir, yes, sir.
n equal to 0, 1, 2, 3 बढ़ता जाएगा. सो लीडिंग टर्म अगर n equal to 0 का corresponding जो टर्म है, if it is a non-zero term, then the leading term would be corresponding to n equal to 0. So let us first find what is the term corresponding to n equal to 0. So let us first find I naught. I naught would be minus a to plus a. I think this would be k cos pi z upon 2a dz, and this would be, I think, k, and then I would have 2a upon pi, and this would be sine pi z upon 2a from minus a to plus. Is that clear? So I think this would be 4a k upon pi. With this would become, I think, this is quite easy to see that pi by 2 sine pi by 2 minus of minus sine pi by 2. This would be 2. So overall, I know that n equal to 0 term is a non-zero term. So corresponding to n equal to 0, the term I naught is a non-zero term. So therefore, the leading term would be v as a function of r. N equal to 0 रखो यहाँ पे. Pn0 is 1, so I will write 1 upon 4 pi epsilon naught. So your potential would be approximately equivalent to the leading term, because we are when I'm saying leading term, means I'm saying for very far away distances. So for very far away distances, your leading term would be dominating term. Is that clear? And I think I naught would be, I will write 4a k upon pi, and n equal to 0 here, if I place it, would be 1 upon. Is that clear? So your leading term would be proportional to 1 upon r. Or you can say the leading
Yes,
term would
sir.
be corresponding to the monopole contribution. Is that clear or not clear?
भैया.
Okay, now in the second case, if you see, this is k sine pi z upon n. So if I just calculate that what would be the total charge, what would be the total charge? So if I integrate from minus a to plus a, this is k sine pi z upon 2a dz, and I know that if I integrate it, I will get 2ak upon pi, and this will be cos pi z upon 2a from minus a to plus a, and cos pi by 2 is 0, cos minus pi by 2 is also 0, this is 0. So your total charge is 0, so your V monopole would be 0. So now no longer your n equal to 1 term would be there. So now you need to see beyond it. So now one needs to see beyond it. So what would be it? So let us do that also. So now again, V as a function of R would be 1 upon 4 pi epsilon naught r ki power n plus 1. I'll write Pn cos theta now, because I think this is certainly clear. Summation n equals to 0 to infinity. And this is from minus a to plus a. This is z ki power n. This is k sine pi z upon 2a. And then this is z. I told you that for n equal to 0, there is a 0 term. So the leading term may correspond to n equal to 1. So let us see n equals to 1 ke corresponding kya integral aata hai. And this is something that I'm leaving to you for the break that we are going to take right now. So from n, so I'm just trying to write the leading term. So I hope the leading term will be corresponding to n equal to 1, and that would be equivalent to cos theta divided by 4 pi epsilon naught r square minus a to plus a z k sine pi z upon 2 dz. Just find this integration and let us see. Let us meet in the first session. Is that clear?
Yes, sir.
Okay, just find this integration. Fatafat se. I'll meet you in the next session. Okay.